Liquid Assets is proudly sponsored by HASA.
Hello, everyone. I'm Terry Arko, and I'm from HASA. And HASA makes liquid chlorine, liquid acid, and different specialty chemicals in the pool industry. And I'm very happy and very privileged today. I'm going to be talking with Ravi Kurani, and we're going to be tackling, I guess, probably the most difficult algae problem in the world right now, which is the Lincoln Memorial Reflection Pond, which seems to have a history of continual algae for a long time, and it seems like a lot of people are very concerned about that algae right now and trying to solve that problem. So I think we're going to have a discussion. We're going to see what we can come up with. Possibly, maybe we can solve that problem too. We'll do our best in this conversation.
Welcome to Liquid Assets. Liquid Assets is a podcast that looks at the world of water through the lens of business, policy, and technology. Today, we have an awesome guest for you. We have Terry Arko from HASA. Terry, how are you doing today?
I'm doing good, Ravi. Thanks for having me.
Yeah. Thanks for coming on.
Sure.
At such short notice, so we have a very topical thing to talk about, and it is the Lincoln Memorial Reflecting Pool. It's been all over the news. It's June 22nd, 2026, just for those in the future listening to this. Can you just walk us through as much as you know of like what exactly happened? Like why is it green? What's going on?
Sure. And my background's with swimming pools primarily, as you know, and you've done a lot of work with swimming pools too. And so I think you understand from that standpoint. A swimming pool, basically, there's everything in a swimming pool, every ingredient there in a swimming pool that encourages algae growth. You've got sunlight, you've got water, you've got nutrients, you've got contaminants, things that get in there. The big difference with the swimming pools are also designed to deal with and prevent a lot of those things just in their basic design. Swimming pools have filtration, they have circulation, they have good movement of water. It's a good pool and a good designed pool. So I think the main thing here is just, the difference of what we're looking at between something that's like a swimming pool that's designed to keep the water clear, deal with algae, deal with filtration and all those things from that standpoint, to where now we have something that's it's about a third of a mile long, I think, 60 feet wide. It was built in the 20s. It doesn't have, it has some circulation and so forth within it, but the circulation and flow is not. In other words, they don't want the water really moving because it's supposed to be a mirror pool, right? So they want the water to be still. And so you have that, first of all, in the design, and then also take the fact that the pool is very shallow. It's 1.5 to 2.5 feet in depth. And, a big, wide open area that is, basically has nothing to shade it. So lots of sun, especially in the heat. And so I think in and of itself, the design of the thing leads to there's going to be algae growth. It's not that hard to grow algae, Ravi. I mean, if you just take a little flat dish or something and put it out in the sun for a while, in a day or two, that it's green. And I think what you have is you have that on a very large scale basis there. And anybody who looks at the history of, the reflection pond going back, you'll see the algae has been a problem since pretty much day one. It hasn't been as bad. I would think maybe in the 20s it wasn't quite as bad because they didn't have the nutrient load in the water systems as much as they do now. We have a lot more nutrient load in our waters, in our open waters now than we did before. So I think it's that's another thing, the nutrients, phosphates, nitrates, things like that are naturally in that water. So you take nitrates and phosphates, you take the fact that there's CO2 naturally in the water, and sunlight, and just a big area of water that's not moving sufficiently, and the surface. the surface is not a real smooth surface. And even with this new, what they've done when they've redone it, you still got kind of a rough surface. These are all things that algae loves. And so it's not going to take long for algae to grow in that situation. I guess I would say, and maybe we'll get onto this, and the managing of it and how it would be managed is maybe something they're looking at more so.
I want to kind of take a step back and for the audience, we have kind of a pretty general audience that spans all the way across from folks in the water industry to folks in the pool industry to just the kind of regular layperson. Let's just backtrack on what is algae? Like what exactly it's obviously like an organic plant, right? That kind of grows. Can you just walk us through the kind of simplistic nature of what is algae?
Sure. And just noting with the general audience and that I'm not a phycologist, so sure. I can kind of give you a basic from maybe a pool standpoint. But algae basically overall is kind of a one-celled plant in a sense. It's kind of it exists in, well, let's put it this way. I think there's about maybe 3,000, 3,500 species of algae that are known. But a lot of scientists and so forth claim that there's probably 300,000 different species of algae in the world. And it can be different types of algae. You can have green algae, and green algae basically, that's the easiest to grow. And I would say that's primarily what's going on in the reflecting pool, because that will happen fast. Green algae is basically just a green slime, and it grows on walls, and it will bloom and blossom, and you'll even get mats that will float on top of the water. Then you can have, like a yellowish kind of a powdery type of algae that will appear. I don't know that they're getting so much of that in the reflecting pool, but they could be, but you just can't see it because of the green. Black algae is one which actually is more of a bacteria. That's like a cyanobacteria. And cyanobacteria is something that it will appear in blotches. It'll appear like little round growths that are actually on the surface. So those are kind of the main pool types. And the thing is, it's omnipresent. It's everywhere. I mean, it can be in the air, windborne, in the dust. It can be on trees. It can be on leaves. It can be on dirt. It can be on grass. It's everywhere. So like I said again, you have that large body of water that's about a third mile long, over 2,000 feet, I think, long, and 60 feet wide, and very shallow. And so, I guess occasionally people get in there too. I don't know if they're supposed to or not. Who knows if people bring dogs there and dogs get in. But algae's getting in there. In fact, it's probably bombarding it from every angle.
Yeah. And if you were going to, I guess, go back to the 20s and redesign this, right? You had mentioned that it's obviously 2,000 feet long, 6.5 million gallons. There's no shade. There's no circulation, right? Which is kind of the key of getting the water moving. And then you have the DC summer heat, which is hot and humid.
Yeah.
How would you have gone back and designed this in the 20s? Like, would you have put a circulation pump, or would you have made it deeper? Like, what would have solved this with the same, I guess, output of wanting it to be a quote unquote reflecting pool, kind of having the still water?
Yeah. I think that's a bit of a difficulty for the purpose that they had it for initially.
Sure.
And I'm sure whoever designed that was just designing that as a reflecting pool. But definitely the depth. I think the depth has a lot to do with it. I think the surface, how they surfaced it. I think originally I heard that the surface was asphalt.
Oh, wow.
Yeah, in the 20s it was asphalt. And the other thing too is that this was built actually. The original pool was built in that area in the Washington Mall is really a lot of marshland. So you don't have real stable soil. And apparently it actually was sinking. It was leaking a lot, or they were losing a lot of water. And I think even now today, that was part of the whole rehab that they were doing of it recently, was because they were losing like 16 million gallons or something of water a year, and they were trying to stop that. And that was part of the resurfacing thing, I think. But there was a rehab done to it in the 80s. There was another rehab in the early 2000s. One of the things they did, I don't know if it was in the 80s or in the 2000s, but at some point they actually took timber, large pieces of timber, to stabilize the soil, because again, from the weight and everything and the soil, it was sinking. The actual pool was beginning to sink.
Oh wow!
Yeah.
So not only was it kind of losing water from it leaking, it actually was.
It also was, yeah. From the soil was just shifting. Sure. Like I said, it was marshland, not real sturdy. So maybe it shouldn't have been built there in the first place, But people learn. But like I said, they sort of reinforced by putting these huge, almost like big giant railroad ties, I guess, over, and then they put the concrete and everything over the top of that, and they redid it. And I think that was in the early 2020s. And at that time, I believe that was a time where they incorporated more of a circulation. However, the goal was still they didn't want it to move so much because it's supposed to be a mirror pool. So I think that's an issue too. I think it's just basically what it is, and I don't know how you fix that, because you're either in a swimming pool, when you have good filtration, at the surface of that pool you see movement.
Yes.
And so I don't. That would be my big fix right there. Good flow, strong circulation, the water really moving, especially under those sunny conditions. That's the biggest problem people face with swimming pools. When you have poor filtration, or now we have these variable speed pumps, and the idea of the variable speed pumps is they can lower the output of the pump and so forth, to save electricity. And it's particularly at peak times, that the power companies want them to run at the lowest, when everything's at a peak. And that's usually in the summer. That's at the peak of the heat of the day, right?
Which is when you need
people to turn their air conditioners down and turn their pool circulation filters on low. Well, that's the worst thing you can do in that situation for algae, again, because what you do is you reduce the flow, you reduce the movement of that water under a lot of heat and sunlight. And algae, like I said, algae loves still waters. It doesn't like moving waters. So that's one thing too. I would say the design of it, if you could get away with having water that's moving, so forth. The other thing they talked about in the original design, they didn't want to have fountains or anything like that as well, again, because you're going to disturb the water. I would say if you could, at some point, at one end or two different ends, even if you had some additional aeration, fountains, movement of the water, those are things too that probably could have helped. Ozone, they didn't have ozone in the 20s, I don't think, or they didn't have it where they could apply it at that. But certainly ozone and UV could definitely help, because, and with HASA, we make liquid chlorine. We would love for them to be using a lot of liquid chlorine, but apparently that's a pretty big expense, I guess, from, to be doing that. You'd have to be doing it daily. You'd have to be feeding it daily. You'd have to be using a lot. And I think, the possibility of chloramine smell, things like that may not be attractive, I guess, that they didn't want as well. But again, yeah.
I want to go back to one thing you said, Terry, before we kind of move to the actual management portion of this. You had mentioned that water in the 20s had less nutrients than we have now, the phosphates, nitrates in the water. What is the kind of, is that just from like farm runoff, or is it just kind of like more nutrients?
I think it's just basically from a lot of different things. I think just the population overall at that point.
Sure.
There weren't communities everywhere like there are now. As there weren't houses that were right on the edge of waters and lakes as much. I think population, pollution, just overall our growth as a society, and more things being used, more chemicals being used. Industrialized agriculture was not as huge then as it is now, obviously. And I guess we learn if you go back and do a history of Chesapeake Bay and the algae growth in Chesapeake Bay from just industrialized agriculture and the increase in all the runoff going into the waters. So that was kind of an assumption I made, but I think if somebody researched that, I think they would find that there's probably less nutrient in the waterways in the 20s than there is now.
Yeah. You kind of preach this holy trinity, right? The circulation, filtration, and chemistry.
Yeah.
That plus, I guess, management of the pool. Now, so we can kind of move to that kind of area. What would your kind of comments be there? How would you manage this pool? What would it look like?
I mean, it sounds like they're trying to get on the right track, maybe by what they're doing. The one thing I know that I'm not exactly sure when this came into play, but I read about nanobubbles. Using it's kind of a nano version of ozone. I guess what it is. Where a regular ozonator will make these bubbles of ozone gas, but they're a certain size, and I guess they dissipate pretty rapidly. Normal ozone will dissipate, within 20 minutes or so of the gas being produced, a normal ozone bubble. But this nano bubbler, they're making very, very, very tiny bubbles, and apparently when they do that, it causes the bubbles become more, neutrally buoyant, so they don't tend to go to the surface as quickly and then burst and disperse. They tend to stay in the water flow or kind of in the water overall for what I read said sometimes it can last for weeks. And so that's putting a lot of oxygen in, and you need that dissolved oxygen. That's a big thing too. When you lose dissolved oxygen and all that, you're definitely going to have a lot more water quality problems overall. Oxidation, right? That's another thing we talk about with swimming pools, right? Besides sanitizing, you're oxidizing. Oxidizing is a huge part of that, and keeping things pure and keeping things clear. So it sounds like they've got this nanobubbler thing going. I'm not quite sure on the hydrogen peroxide. I know they were using a lot of that as well. I know that from a pool standpoint, we have something called AOP, which is advanced oxidation potential. We have a device that does that, and part of the device is they combine ozone with hydrogen peroxide, and that creates hydroxyl radicals. And the hydroxyl radicals will just about kill anything and everything. They're produced very quickly. They don't last very long, but they're very powerful. And so the combination of hydrogen peroxide with a strong ozone like that, and I guess a more residual ozone, is definitely going to create hydroxyl radicals too. So I think perhaps they understand that, and they know that that's another way, non-chemically, I guess, but yet they're using hydrogen peroxide to help in that.
Interesting. And just kind of picking on this nanobubbles thing plus the hydrogen peroxide, I'm just going to kind of summarize what you said. If you're using an AOP system, you're taking basically ozone plus hydrogen peroxide, and you have these little bubbles that are basically creating these hydroxyl radicals that basically kind of break apart the bacteria or kill the algae. And then I guess if you combine that with nanobubbles, the nanobubbles last for longer, kind of as you said, sometimes up to weeks. Yeah. So maybe it is kind of a better or a longer lasting combo than kind of a pure ozone system.
Yes. Yeah, that's the reason for selecting nanobubbles, I would think. So somebody was thinking there for sure. I would just say, even having an ozonator that was generating ozone 24 hours would be a plus. But the nanobubble device is even more of a plus, I would say. But again, this is all kind of in the infancy. I think they're doing these things, introduce these things to solve the problem. And it's, I look at it, I read about it, and being a pool guy, I'm like, I don't know that they can completely solve the problem. I just don't know.
Yeah. If you, I guess if you had a magic wand to wave, and you can kind of take over management here, what would Terry do? Like, what would you come in? You know, we awarded you the contract. How would you solve the problem now, given the problem that you see currently in the news?
Yeah, I mean, I'd say if I could do anything, and if I had a magic wand, I think probably water source would be one. You know,
Interesting.
I would love for there to be cleaner water in the world.
Yeah.
You know, that would be my magic wand overall. And that's the thing too. You know, I think when they initially built this, the water was coming from, it was more city treated water.
Mm.
Somewhere, and this might have been in the 80s or when they did the early 2000s, they shifted to a more of, I guess, what I would say a rural sort of reservoir. That's between, I think it's between the Potomac and a river, and I think the quality of the water is not the same, obviously, as treated water. But that would be the main thing. If I could get better water in there, that would be one thing. I think if there was a magic way to sort of shade it, you know, from the sun, although there are species of algae that grow in the shade. So, you know, but maybe we would reduce that green quite a bit. I think if you could make it deeper and if you could give it a really strong circulation, I don't know, maybe offside of the, you know, the actual pool, you just have the water just being churned and filtered really well, and then it could go back in and be still.
Oh, interesting.
Yeah.
So kind of having like an offline circulation area, so you don't disrupt the
And then
reflective.
you gently introduce it back in, something like that. I'm
Interesting.
sure that, you know, engineers and chemical people and microbiologists and PhDs and, you know, guys like you that are very smart are just pounding their heads right now to come up with that magic wand. So, but it's again, it's three things. It's movement of the water, you know, it's filtration, good filtration at a very small micron level, and chemical treatment. And you know, I know, you know me, I'm a chlorine guy. I've been doing pools for over 45 years, or working with pools, and I still have not seen a better algicide than chlorine, especially with green algae. You know, if you get chlorine correct, it'll knock green algae out very quickly.
Can you combine a chlorine, like a liquid chlorine system with these nanobubbles? Are you able to kind of?
Yeah, I mean, I see no reason why you couldn't. You know, you can combine in pools that have ozone, UV, things like that. You'll use lower levels, but it's very effective. And you know, the biggest thing now, you know, the nanobubbles obviously last longer. So I guess you could say you do get somewhat of a residual, or you are getting a residual, ozone residual. But the thing with regular ozone is it dissipates pretty quickly. UV is strictly contact. I'm kind of curious as to why they might not have added UV to that system too, but I don't know. But you know, both of those don't have residuals, and really, you know, that's why I'm a big fan of chlorine in pools, is because chlorine does leave a residual, and it's just been a proven chemical since, you know, forever.
Yeah.
As far as, you know, antibacterial and anti-algae, very effective.
Terry, you've spent 40 plus years in the pool industry, as you just said. Let's kind of move to pools. You know, we just mentioned that the reflecting pool obviously is a little bit more of a pond. It's meant to be reflecting. You're not swimming in it. Doesn't have a bather load.
Yeah.
Let's just kind of switch topics really quick. Like looking at the folks that listen that have backyard pools, summer's about to come up. What's your tips and tricks there? I feel like getting a few minutes on that would be great here.
Yeah. The biggest thing, again, is just ensuring you have and this has to do with your builder or maybe even your pool pro who takes care of your pool, if you have somebody like that, that you have a good system. You have a good, in other words, you have a properly sized pump. You have a pump that's sufficient to basically move all the amount of water you have in there and move it at a good flow. And then a properly sized filter. What I find in a lot of residential pools that get built is a lot of times that equipment is undersized. And so it's a losing battle to begin with. So making sure your equipment is sized properly so that, again, you're getting a very good turnover. So the turnover just means all the amount of water that's in your pool is passing through that system at a good rate, and it's getting filtered very efficiently. I mean, the physical things cannot be denied, and I would say those are the most important. Now going to the chemical, I think the biggest mistake that people make chemically is they either underuse or they overuse the chemical. And if you underuse, we talk about what's known as free chlorine. Free chlorine is very vital. There's other species or forms of chlorine that can be formed very quickly, especially if you're underusing the chlorine. If you're underusing the chlorine, your chlorine is going to get consumed and used up very quickly by contaminants and things that are in there. The environment, the atmosphere, you're swimming, things are coming off your body, all these contaminants. And so the chlorine will be basically useless. It's not going to be able to do what it's going to do. So that's very important. And so you want to ensure, I always say there's three things that you want to know about your pool chemically. If you're using chlorine, you want to know what the total chlorine is, you want to know what the free chlorine is, and you want to be able to test and know what the combined forms of chlorine are. And as we get into summer, the very simple thing for keeping algae out of the pool is to do those three tests, understand those three tests, and to always ensure that your free chlorine level is always higher than your combined. And so you must know what your free chlorine is, you must know what your combines, and you want to maintain your free chlorine level always higher than your combines. And that goes to pool professionals and pool service folks as well, to know that and understand that when they do the testing. That's where you're behind the eight ball, because pools, especially outdoor pools, there's such an onslaught of contaminant, from swimmers, the environment, everything that gets in there. And if you're not properly dosing chlorine, and if you don't have that proper free chlorine, then you're basically losing the battle and you're going to just be fighting a lot. That would be my biggest advice. Understand what total chlorine is, understand what free chlorine is, understand what combined is, and realize that the free chlorine must always be higher than the combined.
Awesome. Terry, we always love to kind of get in the mind of the guest. 40 plus years in the pool industry. What was that inflection point? Was it like your kind of first job? Like how did you get into the pool industry? What's the story of Terry?
It's kind of funny because I'm one of those people, and like a lot of people here in the pool industry, that fell into it when I was very young, very, very young. I was just in my early 20s. Started out cleaning swimming pools. Needed a job, had a friend. He said, come clean swimming pools. I guess what I'll say throughout not entirely, but I guess earlier on in that 40 years, I tried so hard to get out of the pool industry many times. And it seemed like the harder I tried to get out, the deeper I got into it. And so for me, I've been very fortunate, and I'm very grateful because so many people encouraged me, so many people helped me to get to where I am today. And so a big part of it was just I wanted to leave. Somebody said, "Hey, here's another opportunity. Don't leave, but how about if you do this?" And I said, okay. So then I did that. Then I might have got a little tired of that after a few years and said, I don't know. I think I want to do something else. Okay, well, how about if you do this and you try this? And so I just pursued kind of everything and anything in the pool industry you can do rather than getting out. And after 45 years, I think I've probably done about everything you could do, other than I don't think I've completely built a swimming pool from scratch. I've worked on a lot of them and come close to it, but that's probably about the only thing I haven't done. But I've developed chemicals. I've worked with scientists, microbiologists, lots of smart people. And I've learned a lot along the way. So.
Terry, we're coming close to the end of the podcast here, and I ask a question to everybody, and it's: do you have a book, a movie, or a TV show that has profoundly changed the way that you view the world?
Yeah, and again, it has to do with water, and that's another thing. I grew up in Southern California and grew up near the beaches, and I've always had a love for water, just being in the water, around the water, and so I have a lot of books in relation to that. But the one that I really go to a lot is by Masaru Emoto. You've probably heard of it. He's a Japanese scientist. The one I like is called The Hidden Messages in Water.
Yes.
And just talks about the structure of water. And the really interesting thing is, we talk a lot about water in our environment, but this really talks more about the environment and how the environment affects water, and even we as people, what we do with the water and how we act and the things, making reflecting ponds like that, and what we're doing with the water in that reflecting pond. And I think we can see the effect of that upon the water. And so that was a fascinating thing to me to see, that even from the standpoint of, and I'm a really philosophical guy, so I kind of like, spirituality and things like that. But to even see how, we're made up of water largely, and we have emotions and things like that. And it's just interesting if you get into Emoto's work and you see how even negative emotions change the structure of water. Pretty fascinating stuff. So, Hidden Messages in Water I love that book. And I just recently, on Nova, on PBS, I watched a special called Poisoned Water, which was about basically what happened at the Flint, Michigan, the whole Flint, Michigan situation.
Oh, sure.
And I would recommend anybody who has anything to do with water, if you're a pool service tech, if you're an industrial wastewater person, microbiologist, whoever you are, anyone who has anything to do with water should watch Poisoned Water and see what's going on and see what can go on, if we mismanage our water systems. So that would be two for me.
We'll throw both of those on the show notes. Thanks a ton, Terry.
Thank you.
Terry, where can the audience find you? And do you have any last parting words for the lesson from the most famous algae bloom in America right now?
Yeah, I'm with HASA, so certainly you can go to HASA.com and you can, find my information there. My email, which I guess you could post, which right now is terryarko@hasapool.com. So yeah, those are kind of primary ways. Definitely, if you go to HASA, you can find me. And yeah, I think that's mainly it. Unless what was the other part of that you wanted me to?
Oh, just do you have kind of a final takeaway from the
the final takeaway I would say is, I think it just has to do with design. And when you design something, designing it properly, sometimes things can't be done, and people get ambitious, builders get ambitious, they try to do things or attempt things, and sometimes maybe those things shouldn't be attempted, or you just realize what you're going to have to deal with in the long run. So
amazing. Thank you so much for joining us, Terry.
Yeah. Thank you, Ravi.